Hello, welcome to 7.5 homework help. Let's do this. I'm actually going to make two different videos. The first video I'm going to do on here right now, and I'm going to go through ready, set, but then the go part, hold on, is constructions, so I shouldn't do that on here, so I'll do that on a second video so I can use my dock camera. All right. So if you're looking for that, go to my second homework help video for today. Okay. The first part, for each set of lines, use the points on the line to determine which line is the image and which is the pre-image. Okay. Your regular image is just going to be the ones without the prime. So let me comment. So this is my image. Sorry, this is my pre-image. Pre-image. And this is my new image. So the pre-image is the one that you're transforming, changing in order to get to the actual image. So like for number 2, NM is the pre-image, this is the image. Okay. So there's that. Oops. Okay, description of transformation. So I'm starting here, and I'm going up to M prime, N prime line. Hold on. I don't like having random spots there. Okay. Well, it looks like I'm just going 1, 2, 3, 4. From M to M, I'm going up 4. Should I draw it? Okay, I'm going up 1, 2, 3, 4. Going up 4 there. Let's see if I'm doing the same on N. 1, 2, 3, 4. Okay. So that works on both. So that means my transformation is just translating up 4. So you can either write a little bit smaller. Yeah, there we go. Translate up 4, or you could write it as X doesn't change, but you're adding 4 on to Y. Oops, sorry, like that. Either one is fine, whichever way, or both. Then you have to find the equation for the pre-image line. So equation for this line. Right, so when you're writing equations for lines, you should automatically think of y equals mx plus b. Okay, y equals mx plus b. So for my pre-image, this line down here, my y-intercept is -2. All right, so b equals -2. And then my slope, let's see, I'm going to start at M. So it looks like I'm going up 1, 1, 2, 3, over 3, up 1, 1, 2, 3, up 1, 1, 2. Okay, so I'm going up 1 over 3. So M equals up 1 over 3. So for your equation, that's just y equals your slope, 1/3 x, and then your y-intercept, which is -2. So go ahead and pause me and try and write the equation for the other line. Okay, so for the other line, these lines look like they're parallel, but we'll double check. Actually, they should be parallel because we don't change them at all. We'll double check, just cover our bases. So my y-intercept for this one is 2, which makes sense because I'm going up 4, so I'm going from -2 to +2, and then my slope is the same, up 1 over 3, up 1 over 3. So y equals 1/3 x plus 2. Number 2, is also going to be a translation, so I'll give you that hint. Is it some type of translation for the transformation? Okay, here we go. What's this one about? Okay, this is another translation. I'm not going to tell you what it is, but it is another translation. You're going to write the equations for the line. Okay, write an equation for a line with the same slope that goes through the origin. That means write an equation for a line with the same slope as the lines above. And the y-intercept is 0. It goes through 0, 0. So it goes through the point 0, 0. Your y-intercept for this is going to be 0. So y equals some slope. You're going to figure that out. I'm not. X plus 0, or just y equals mx. Or you can leave the 0 off. So figure out that slope, and then you'll be done with number 4. With the same slope as. All right. Number 5. Write the equation of a line perpendicular to these. Okay, so perpendicular, so you're going to have to flip and switch your slope, and it goes through the point O prime. So that's over here. So use point slope form for this. So y equals mx minus, well, you don't have to. I would. X minus x1. Okay. Point slope form. So y equals your slope. You're going to figure out the slope. And it goes through the point O prime. So O prime is at -2, and 0. So that's just x. That becomes +2. And then +0, or you can just leave it off. So all you have to figure out is the slope, and then you're done with number 5. Okay. Okay, 6. Oh, no, okay, just 6. So it says, match the table values below with the proper function rule. The function, okay, I'm telling you this. The function rules are written in point slope form. The slopes are all -2. The slopes are all -2. You can tell that by looking at your tables. They're all going down by 2. They're all going down by 2. They're all going down by 2. Okay, so you just need to match up the points. So I did A for you. Okay, so once again, point slope form is f of x equals your slope, x minus x1 plus y1, where x1 and y1 are your points from the table. Okay, so point slope form, you just need the slope and then a point. And you just fill in this equation with a slope and a point. Okay, so for A, which is 3, okay, I have x minus 1, so that means the point is +1 and +8. So you just find the table that has +1 and +8. Okay, go ahead and figure out B. Pause me and figure out B. Okay, so for B, your slope, or sorry, not your slope, your point is once again x minus 1, which means it's just a +1. You're substituting a +1 into this equation. And then +12. So find the table that has 1, 12 as a point. Okay, and it is, here it is, 1, 12. Okay, so that is B. Okay, so you're going to do that for C, D, and E. All right. Here we go. So, use triangle congruence criteria to justify conjectures. Goodness. So in each problem below, there are some true statements listed. So they're telling you these things are true. From these statements, a conjecture, a guess, if you will, about what might be true has been made. Using the given statements and conjecture statement, create an argument that justifies, okay, so you're trying to prove that this is true. Well, using this, yes, you're trying to prove that this is true. All right. So, true statements. Point M is the midpoint of DB. Okie dokie. And then they are telling us that angle ABD, angle ABD, so that's this angle right here, angle ABD, is congruent to angle BDC. BDC. So that's this angle right here, BDC. Okay. And they are telling us that AB is congruent to DC. Yeah, I'll change my color just for funsies. Change color. Green. So AB is congruent to DC. Okay. Okay, anyways, and then they tell us this is the midpoint. Okay, so conjecture. Angle A is congruent to angle C. Is this conjecture correct? And then we have to argue that we're right or wrong. Okay, oh, sorry, 1 second. Hold on, sorry. Sorry. Okay, here we go. So, what we're trying to figure out with, let me look. Yeah, you're trying to use triangle congruency. So right now I know a side and an angle. All right, well, that's not enough, but I also know, wait, hold on. So I'm trying to figure out if, is it gonna let me highlight? Oh, it is. Oh, it's aggressive highlighting. If this triangle is congruent to this triangle. Okay, that's what I'm trying to figure out. Well, I know an angle and I know a side, but they also share this side. So that is my key here. I'm going to get rid of my highlighting. There we go. They share this side, not green. Sure. They share that side. So that means I have side, angle, side. Side, angle, side. So, side, angle, side. I'll come back up to here in a second. I don't have a triangle symbol. Triangle. Actually, we did go. I'll just draw it real quick. Let's see. I have triangle. It doesn't matter. Let's do DAB. DAB is congruent to, so I did DAB, DAB, so I'm going to do BCD. It's congruent to triangle. Oh, there we go. Now I forgot what I said. DAB is congruent to BCD. BCD. Okay, if you wrote these, if you started, so I did DAB, if you did BAD, then you would just do DCB. Okay, so you're not going to have the exact answer here, and that's fine. Just make sure they all match up. So like D is equal to B, A is equal to C, and once again, okay, D is equal to B. D is equal to B. All right. So I have congruent triangles by side angle side because DB is, okay, come over here, is a shared side. Means it is congruent to itself. So then, if my triangles are congruent, is angle A equal to angle C? Well, I just said it was. Yes. Yes. Since the two triangles are congruent by side angle side, then all corresponding angles are congruent. Congruent. Something like that. Okay, so you're proving that the triangles are congruent, and then that's why the conjecture is correct. So you're going to do similar for 8 and 9. 9 had something tricky, I thought. Oh, well, okay. Maybe I should have done number 9. So ADM, triangle ADM, is a 180-degree rotation of CMB. Okay, if you're rotating a triangle 180 degrees, that means it's going to stay the same, right? When we are rotating our triangles last chapter, or whatever that was, so we were rotating triangles. We did that earlier this chapter. Okay. They don't change shape. So if ADM is 180 degrees of CMB, then that means that AM is going to be equal to CM. And then put 2 lines on this one. 1, 2, 1, 2. So triangle ADM is just a 180-degree rotation of this one. Okay. So that means these guys are the same. These are the same. Oh. And also the other, I don't like how the book answers this question. Surprise, surprise. Because then then this side would also be the same. This side, 1, 2, 3. That show up, kind of. It's also going to be the same as this side. ADM is a 180-degree rotation of CMB. Oh, they want us to prove these two. Okay, never mind. Okay. I got it. Never mind. We're good. So those two triangles are congruent to each other because they are just rotations. All right, so we're trying to prove that this triangle, AMB, is congruent, or sorry, ABM. I mean, it turns out the same, but ABM. Trying to prove that that triangle is congruent to the bottom triangle. Okay. Well, they already have, I'm going to get rid of that. They already have 2 sides that are congruent. So we just need a third thing. We either need a third side or we need the angle in the middle. Okay, so unfortunately, these look congruent, but we don't have any proof that they are, right? We know that these 2 sides, we know that these sides are congruent and these sides are congruent. But we don't know that these sides are. There's nothing that's told us that. So we know, this is throwing you back to geometry last year, that this angle, let me get a different color. Sure. This angle, wow, I drew that really well for once, is equal to this angle. Do you remember that? That's because these are considered vertical angles. Here, let me give you a better definition. So vertical angles okay, well, let's go over here. So vertical angles, there you go. Opposite angles made by 2. Okay. Okay, and they are congruent. Vertical are congruent. So this angle is congruent to this angle, and we don't need to know this, but these are also vertical angles, this guy and this guy, so those would also be congruent. Okay, those are also vertical angles. They're opposite angles made by 2 intersecting lines. Okay, vertical angles. Anyway, so now we know side, angle, side. So, yes, yes. And then you're going to talk about how, you know, the sides are equal, and then what is that? Angle A, angle AMB is congruent to angle AMB. CMD, CMD, B by, because they are vertical. Okay, so that's that, and then by definition of rotation, side AM is congruent to side CM, and side PM is congruent. Oh, I don't know why I'm typing it out. It's congruent to DM, MB, BM, geez, BM. So that's how we got our start. And then you just had vertical angles. I think that was it. Did I forget anything else? Nope. And so that leads us to side angle side. So that gives us congruency by side. All right. Okay, I have to move on to the other type where I'm going to do them under my document camera. So if you need help with 11 through 17, check out my other video.